Hello everyone and welcome back to another video provided by SVSU's online tutoring. My name is Joel and today we'll be discussing section 9.1 exponential functions, and the topic for this video will be on graphs of exponential functions. So what we're dealing with now are functions where we have the variable as our exponent. So if I have f of x equal to 3 to the x power, that's the type of function that we have to deal with now. And so what I'm going to do is that I'm going to give us two different types of functions, and we'll be working with I guess you could call it the positive exponent powers, and then we'll look at other functions where we're given the exponent where the exponent is negative. So if we want to graph these two functions, the easiest thing to do is to create a table. So I'll have x up here, and if I can draw a straight line, maybe I can just do this instead. There we go. And then, yeah, there we go. So I have x there, and I have f of x here, and g of x here. And then I'm just going to put my x values that I want to evaluate the function at. Okay, so I have 5 x values, and what I want to do is that for each x value, I just want to plug it into my function and evaluate. So if I'm looking at f of x, I put in -2, I'll have 3 raised to the -2, which is really 1 over 3 squared, which gives us 1/9. So this is 1/9. And if I have f of x, or f of -1, that's 3 raised to the -1, which is really 1 over 1/3 raised to the first power, and so that's just 1/3. Fix that 3 right there. And we just go on and continue. So we get 1, f of 1 is 3, and f of 2, 3 squared, which is 9. And likewise for g of x, if I write that over here, we start with -2, which is 5 raised to the -2 power, which is really 1 divided by 5 squared, and that's 1 over 25, so 1/25th. And I'm just going to fill this in now. There we go. Okay, so I filled out the table, but what does the graph look like? So I can draw that over here. Y, then x. And I want to make sure that put in my tick marks for these x values. So -2, -1, 1, 2, and 0 of course is right here at the origin. So for f of x, I'm going to draw the points with 0 circles, or 0 dots. So at -2, x is 1/9, and I should probably put on horizontal ticks as well. Rather than putting 25 ticks, I think I'll go by 5s. So this will be a little weird for graphing f of x, but for g of x it'll be fine. So that's 5, 10, 15, 20, 25. Okay, so if we're starting with f of x, we go to -2, and that value is 1/9, so it's barely above the -2 right there. And then -1, that's 1/3. Again, it's barely above the x-axis, and it's barely above the 1/9 because of my scaling factor in the y direction. And so at 0, it's 1, so about 1/5 right there. And when x is equal to 1, f of x is 3, so now we're a little higher. And then when f of x is 2, or when x is equal to 2, f of x is 9. So at 2, and we're at 9, so we're like right there. And so you can see that the graph begins to start begins to look like this. So if I come in, and it's very difficult to draw this straight, especially an exponential function, but you can imagine then if I had 3 cubed, it would be 27, which would be above 25. So let's just draw that for some perspective here. So 30 is right there, and then 27 would be in between those two, about. So right up there. So if we go up here, I missed it completely. So there you go. You can see how it begins to climb very rapidly once we start hitting those higher x values. And then for g of x, I'll do it in green, I suppose. So it's 1/25 at -2, which is even smaller than 1/9, and 1/5, which is smaller than 1/3. They have the same y-intercept, and x equal to 1, which is 5, and then 25 at 2. Go to a lighter shade here, and we can see that the growth rate for each are different. So this one in red was f of x equal to 3 to the x, and this one in green was g of x equal to 5 to the x. Okay, so that does it for positive exponents, but what if we're given negative ones? So we have f of x equal to 3 raised to the negative x, and g of x equal to 5 raised to the negative x. So again, we want to do our table. These ones are a little better. Okay, so when we plug in -2 for x in f of x, we'll get this. So -2, and the negatives cancel each other out, so we get 3 squared, which is 9. And that'll hold true for -1 as well. So I'll just go ahead and fill out this table. That should be a 3, not a 1. And then this is 1/3, and then this is 1/9. And it's the exact same thing for g of x. So as you can see, the two tables are just flipped around, or at least their output values are. So then the graph should be giving off the exact same image, but flipped. So again, let me draw my tick marks here. And in my example, I realized that I went by 3, so I think I'll do that here. So 3, 6, 9, 12, 15, 18, 21, 24, 27. Okay. 3, 6, 9, 12, 15, 18, 27. Doing this by hand does take a while, but sometimes it's worth it. So graphing the first function, we're at -2 and 9, and then -1, 3, and then at 1, 1/3, and then 1/9. So you can imagine that the function is coming down like this. Imagine that it's a smooth curve and that there's no little bump here. And then g of x, we're at -2 and 25 up here, and then 5 down here, and again at 1, 1/5, and then 1/25. And so if we come in You can imagine that it would look something like this. So again, extremely steep decline. Let me go ahead and label these. So we have f of x equal to 3 to the negative x, and g of x equal to 5 to the negative x. And what I want to do is just, real quick, if I select the graph here, I can move it up here. We can see that the two are similar, but because of their opposite sign in the exponent, they're just simply flipped. And the scaling's a little bit different on them too. But if you were to do this in like a graphing or scientific calculator or something that's able to display graphs, you would get this exact image, but flipped about the y-axis. So what are some characteristics that these exponential functions have? Well, their domain, switch my pen, their domain is defined for all x, so that ranges from negative infinity to positive infinity. But their range, however, only goes from 0 to positive infinity. So as you notice that if we continue on going with negative, well, if we had the positive exponent, so f of x equal to 3 to the x, if x continued to get more and more negative, it would never go past 0. It would just give us a smaller and smaller fraction. So if x was equal to negative 10, we would get f of negative 10 equal to 3 to the negative 10, which is just 1 over 3 to the 10th power. And that's an incredibly small number, but it's not negative, so it never crosses over the y-axis. And each of them had a y-intercept of 0, negative 1. And that's just because anything raised to the 0 power gives you 1. It's a pretty obvious fact there. And so, again, with the fact dealing with the range, the asymptote, so you can call this the horizontal asymptote, put a little h dot there for horizontal asymptote, is actually the x-axis. So, oh yeah, I said earlier that the range never crosses the y-axis. I misspoke there. It never crosses the x-axis. So, and that's true for both of these guys. So none of these functions cross the x-axis, and that's because if we're dealing with a positive exponent, the more and more negative we get, we just get a smaller fraction. And for negative exponents, the more positive we get, the smaller fraction we get. But it never crosses. And I think that does it for this video. In the next one, we'll actually deal with transformations of exponential functions. So this one is the ones in this video are pretty stagnant. They're not too interesting. But there are other ones where we can have f of x 3 raised to the x minus 2, for instance. And so that results in different characteristics other than the ones circled in red here. Okay, see you next time.